In this video, I'm going to talk about adding and subtracting vectors. There are two methods to add and subtract vectors. One is graphic, which is drawing, and it's called hit-to-tail method. And the other is mathematical, which is adding the x and y components. We'll talk more in details as we go on. I'm going to start with a familiar example. A car is driving in a straight line from city A, travels 5 kilometers west. First of all, let's agree on a direction. This is north, south, east, and west. So a car travels 5 kilometers west would be a vector going in this direction. Then 7 kilometers north would be a vector going in this direction. 3 kilometers east would be a vector in this direction. 2 kilometers south would be a vector in this direction. 5.66 kilometers northwest. Now this is north and this is west, and it's exactly in between. It's a 45-degree angle. So let's go back here. 5.66 would be a vector in this direction. Of course, to arrive at accurate results, we'll have to do an accurate graph. Let's take inventory of what we have. We have 5 vectors. Vector 1, R1 equals 5 kilometers west. Vector 2, R2 equals 7 kilometers north. Vector 3, R3 equals 3 kilometers east. Vector 4, R4 equals 2 kilometers south. And the last vector is R5 equals square root of 32. Okay, well, these are obviously vectors. They have a magnitude and a direction. Let's try to draw them. R1 is 5 west. Let's assume that city A is right here. R1 would be 5 units going in this direction. Let's assume that each one of these squares is 1 kilometer, so that would be starting here, 3, 4, and 5. R2 would be 7 north. R3 is 3 east. So that would be 1, 2, and 3 east. R4 would be 2 south. So that would be going downwards. 1 and 2. And the last one would be R5 square root of 32. I chose the square root of 32 on purpose. Let's draw a triangle and explain why 32. The direction of the last vector is northwest, which is 135 degrees from the x-axis. That means this angle here is 135 degrees. It also means that this angle here is 45 degrees. Since this is a right triangle, that means this is 90 degrees, and this would be 45 degrees as well. What that really means is this side of the triangle equals this side of the triangle. This is in the x direction and this is in the y direction. We could also use the Pythagorean theory. This is r, and it equals square root of 32. Using the Pythagorean theory, r squared equals x squared plus y squared. Since x and y are equal, that would equal 2x squared. R equals square root of 32, and r squared equals 32. So plugging this in, 32 would equal 2x squared, and x squared equals 16. X is 4, and y, which equals x, is 4. So this here is 4 squares in this direction, the negative direction, and this here is 4 squares in the positive direction of y. To draw vector 5, now we know we have to move 4 squares in the negative direction of x. This would be 1, 2, 3, and 4. And 4 squares in the positive y direction. 1, 2, 3, and 4. And this would be R5. I would like you to notice one thing. All these vectors added would get you from this point to this point, regardless of sequence. As long as you start from this point, you will reach this point, add in all these vectors. Whether you start with R5, and then 2, then 3, then 1, then 4. For a simple reason. That's called the cumulative property in math. When you add in, let's say, 4 plus 2 would be the same as add in 2 plus 4. Adding vectors is no different. Now, if you look back here at the graph, you notice that the tail of a vector starts at the head of another vector. And that's why this method is called head to tail. So the resultant vector, in this case, and let's draw it in a different color, is going from city A to city B. And this vector, shown in green here, is the resultant of adding all these vectors. That's called the head-to-tail method to add vectors. The mathematical method of adding vectors implies that vector R, the resultant vector, equals the resultant x component vector plus the resultant y component vector. The x component of the resultant vector would equal the R1 x component plus the R2 x component plus the R3 x component plus R4 x and R5 x. The first vector traveling west, so it's moving negative 5x and 0 in the y direction. The second one would be 0 in the x direction and plus 7 in the y direction. The third one is going east, plus 3 in the x direction and 0 in the y direction. Fourth one south, 0 in the x direction, negative 2 in the y direction. And the last one, as we figured using the Pythagorean theory, was negative 4 in the x direction and 4 in the y direction. So this would be negative 5 plus 0 for R2 plus 3 plus 0 and negative 4. And this is negative 6. For the y component of resultant vector R will be the addition of the y components, 0 plus 7 plus 1 minus 2 plus 4. So it's adding 0 plus 7 plus 0 minus 2 plus 4. And this would be 9. The resultant vector R equals negative 6 in the x direction plus 9 in the y direction. Let's try to draw it and see if it matches. If this was the origin, this would be negative 1, negative 2, 3, 4, 5, and 6. All these are negative. So we're going to this line here. And positive 9 from the origin in the y direction. So that would be 1, 2, 3, 4, 5, 6, 7, 8, and 9 up to this line. You could see this matches. And this line would be from here to here. And that exactly matches. Rule of thumb, when you have a vector, if you reflect in it where you squeeze in the angle, you use a cosine. If you reflect in it to where you stretch in the angle, then it's sine. Squeezing the angle is cosine, stretching the angle is sine. I know this might look like a complicated problem, but it really isn't. All you have to remember is the stretch and squeeze the angle rules. You need to reflect everything on x. Anything on this side is positive, anything on this side is negative. Then you need to reflect everything on y. Anything on this side is positive, anything on this side is negative. And after that, you just add them together. Vector A would be 5. Now we're squeezing the angle. That would be 5 cosine 45. So that's A. Vector B would be 7 cosine 80, since we're squeezing the angle. That's 7 cosine 80. On this side here, G is 9 and the angle is 70, but when you reflect it on X, you're really stretching the angle. So this is 9 sine 70. F is 8, You're stretching the angle 50, so that's a sine. A sine 50. Now let's do it on the other side. We have vector C, which is 4, and we're stretching the angle to reflect it on x. That would be -4, since it's on the other side, -4 sine 25. Vector D is -6, and we're squeezing the angle, so that's cosine 35. Vector E is -7. We're stretching the angle, so that's sine 75. Add those together, you have your resultant vector R of x, the component of x. Let's do it for y. A is 5, stretching the angle, so that's sine 45. B is 7, we're also stretching the angle, so that's sine 80. C is 4, we're squeezing the angle, so that's cosine 25. D is 6, we're stretching the angle, so that's sine 35. And down here, those would reflect negative side, so they'll all be negative. E will be 7, so that's -7. You're squeezing the angle, so that's cosine 75. F is 8, it's -8 on the negative side of the axis. And we're squeezing the angle, so that's cosine 50. And then you have G, which is 9, so that's -9. And we're also squeezing the angle, cosine 70. The sum vector of all that mess would equal the sum of all the x components and the sum of all the y components. All the x components on the right hand side were positive, right here. All the components on the left-hand side were negative. That's why they were subtracted here. Once you figure this out using a calculator, the magnitude of the x component is 5.97. For the y component, all the components on the vertical axis, the y-axis on top, were positive right here. And all the ones on the bottom were negative, subtracted right here. And the grand total was -21.45. Once you draw this, this is your sum vector. This is the x component, and this here is the y component. The magnitude of this vector R, now that we know the x and the y components, we could draw the vector, and this is the sum vector. We need to find out the magnitude and the angle. The magnitude is found out the Pythagorean theory, so this is Rx, 5.97 squared, and Ry, -21.4 squared, and R would be the square root of that, 22.27. The angle, we know that the tangent of theta would equal pi over x. This is x, and this is y. So the tangent would equal -21.45 divided by 5.97. And let's get the calculator. 21.457 and the negative divided by 5.973. That would equal -3.6. -3.59. Theta, the angle, would equal the inverse tan of -3.59, which would be, click on inverse tan, and the angle is -74.44. This here is -74.44, which means measured counterclockwise from this angle, this would be 285.56. So now you have all the specifications you need for the sum vector R. Its magnitude equals 22.27, and its direction defined by theta be 285 degrees. Good luck, and I hope to see you in my next video.